When you gaze at the night sky, you're not seeing stars as they are now, but as they were, sometimes thousands of years ago. Their light is a message from the past, connecting us to cosmic history. This simple fact sparks a deep curiosity. What if we could truly travel through time? Imagine witnessing the building of the pyramids or leaping forward to see the cities of tomorrow. Time travel isn't just a fantasy, it's a reflection of our desire to understand our place in the universe. We want to know where we came from and where we're going. The idea of controlling time is the ultimate quest for knowledge. But is it possible? Or is it just a story we tell ourselves? Science, our best tool for understanding reality, has surprising things to say about time. The laws of physics, especially those discovered by Einstein, reveal that time is not just a ticking clock. Time can be bent, stretched, and maybe even navigated. The universe is full of possibilities we're only beginning to explore. So, let's embark on a journey. Not through space but through time itself. We'll explore the science, the theories, and the big questions. Can we visit our ancestors, see the fate of our planet? Our exploration of time travel begins now. Let's see where the river of time can take us. Before we dive in, let's define what we mean by time travel. At its core, it's about changing your position in time, just as you move through space. We're all moving into the future, 1 second at a time, but true time travel means breaking free from this steady march. There are two main ideas: traveling to the past and leaping into the future. Traveling to the past means arriving at a moment that's already happened, a world that no longer exists. Traveling to the future means skipping ahead, arriving in a time far beyond your own, while you barely age. Both ideas challenge our understanding of reality. Time travel is about freedom from the relentless one-way arrow of time. It's the ultimate rebellion against aging and fate. Whether it's meeting dinosaurs or your great-grandchildren, the core idea is the same: navigating time as easily as space. But both forms come with unique challenges and paradoxes. Can we ever become masters of our own timeline? That's the grand challenge we'll explore. Time travel is more than fantasy, it's a question about the very nature of reality. Let's see what science has to say. The adventure continues. Let's talk about real science, and Albert Einstein. His theory of relativity changed everything, showing us that time is not constant. Time is relative. It can slow down or speed up depending on how fast you move. This is called time dilation. And it's a proven fact. Imagine you have a twin. You stay on Earth, your twin travels in a spaceship near the speed of light. For your twin, only a year passes. For you, decades might go by. When your twin returns, they've effectively traveled into Earth's future. This isn't just theory. We see it in action with GPS satellites, which experience time differently due to their speed and position. Without correcting for time dilation, GPS wouldn't work. So traveling to the future is possible, at least in theory. The catch? You need a spaceship that can approach the speed of light, far beyond our current technology. The energy required is immense, but the laws of physics don't forbid it. If we could build such a ship, astronauts could return to an Earth centuries older. It's a one-way ticket. You can leap forward but not back. The universe allows travel to the future. The challenge is engineering, not physics. For now it remains a dream, but one grounded in real science. The future is, in a sense, open to us. But what about the past? That's where things get strange. Traveling to the past is where science gets truly weird. Enter the idea of wormholes, tunnels through space-time predicted by Einstein's equations. Imagine space-time as a sheet of paper. Fold it, poke a hole, and you have a shortcut, a wormhole. In theory, a wormhole could connect two distant points in space or even two different times. If you move one end of a wormhole at high speed, time dilation could create a time difference between the ends. Step through, and you might emerge in the past. Sounds like a time machine, right? But there are huge problems. We've never seen a wormhole, and they'd likely collapse instantly. To keep one open, you'd need exotic matter with negative energy, something purely hypothetical. We don't know if such matter exists, so while wormholes are fascinating, they remain speculation. No evidence, no stable wormholes, and no exotic matter, at least not yet. The past remains out of reach, but the idea keeps physicists dreaming. For now, it's science fiction. Suppose we could travel to the past. We'd face a huge problem, the grandfather paradox. If you went back and prevented your grandparents from meeting, you'd never be born. So, who built the time machine? It's a logical loop, a contradiction that seems impossible to resolve. This paradox is a major argument against time travel to the past. How could the universe avoid such contradictions? One idea is a self-correcting timeline. No matter what you do, you can't change the past. The universe would conspire to keep history intact. You could visit, but never alter, the past. Another idea is the many worlds theory. Every change creates a new parallel universe. If you prevent your grandparents from meeting, you create a new timeline where you were never born, but your original universe continues. This avoids paradoxes, but at the cost of spawning new realities. Both ideas are fascinating, but unproven. The paradoxes of time travel to the past remain a cosmic conundrum. The universe seems to resist contradictions. For now, the past is protected, by logic or by the laws of physics. Time travel to the past may be forever out of reach, but the debate continues, and so does our fascination. Science fiction brings time travel to life in ways science can't, yet. Think of the DeLorean from Back to the Future or H.G. Wells' classic Time Machine. These stories make time travel feel almost possible, even if the science is pure fantasy. They explore the consequences of changing the past or glimpsing the far future. In Back to the Future, Marty McFly nearly erases his own existence, a playful take on the grandfather paradox. Doctor Who introduces fixed points in time, events that can't be changed, echoing the idea of a self-correcting timeline. Science fiction uses time travel to ask, what would you do with such power? Would you fix mistakes, save loved ones, or change history? These stories focus on the human element, the hopes, fears, and moral dilemmas of time travel. They remind us that even if the physics is complex, the questions are universal. Science fiction keeps our fascination alive. It's a playground for our imagination, and sometimes it inspires real science. The line between dream and discovery is thinner than we think. What do scientists think about time travel? Stephen Hawking was skeptical about travel to the past. He even threw a party for time travelers, but no one showed up. He proposed the chronology protection conjecture. The laws of physics prevent time travel to the past, protecting reality from paradoxes. Hawking believed that any attempt to build a time machine would destroy itself before it could work. Other physicists, like Kip Thorne, have explored the idea of wormholes. If exotic matter exists, a wormhole could, in theory, become a time machine, but there's no evidence yet. Most experts agree, travel to the future is possible in principle, thanks to relativity. Travel to the past faces immense hurdles, paradoxes, exotic matter, and unproven theories. The universe seems to prefer moving forward. For now, the past is closed. But the future? That's still open for exploration. The debate is far from over. The universe has rules. One of the most important is causality. Causes come before effects. Time travel to the past would break this rule, creating paradoxes and logical chaos. Causality is woven into the fabric of physics from stars to chemistry. Violating it could unravel reality itself. There's also the problem of energy. Creating a wormhole or exotic matter would require unimaginable amounts of energy, far beyond our reach. The universe might allow time travel in theory but make it impossible in practice. These aren't just technical problems, they're fundamental barriers. The laws of thermodynamics, conservation of information, and causality all seem to block journeys to the past. Time is more like a one-way river than a road. We can speed up our journey downstream, but turning back seems forbidden. The present is where we're anchored, and maybe that's for the best. The universe keeps us moving forward. So, is time travel a real possibility, or just a dream? The answer depends on direction. Traveling to the future is scientifically possible. Relativity shows us how. The challenge is building a ship fast enough, not breaking the laws of physics. A one-way trip to the future could be a destination someday. Traveling to the past, though, is another story. Every method, wormholes, exotic matter, is purely theoretical. Paradoxes and the laws of causality stand in the way. The universe seems to protect its timeline. So, the future is a potential destination, the past, most likely, a dream. For now, we're passengers on the river of time, moving forward. Our choices matter, our actions have consequences. We have one timeline to live, let's make it count. The present is a gift from the cosmos, and that's worth cherishing.